How can we send commands from an LS PLC to an LS drive? So today we want to connect the LS PLC to the LS drive via the 485 network with the Modbus protocol. What we want to do is that we came to use 3 people. We put one of these in for forward mode, one for reverse mode, and we also used a stop. We connected these people to the digital inputs of the PLC. Now the way to connect the PLC to the drive is like this. As you can see on the drive, we have a positive S and a negative S that are related to the 485 network of the drive. And on the PLC, we have a positive 485 and a negative 485. Now what we have to do is connect the positive S to the 485 positive of the PLC. We connect the negative S to the 485 negative of the PLC. Let's write the program together. As you can see, we have entered the XG5000 software environment. The first thing we do is set up the network, which is through this part of our channel 2. We use the RS485, set the baud rate to 9600, put the station on the queue, and set the operation mode to use P2P on channel 2. In this section, a window will open for us and we will set channel 2, which is related to 485, to the RTU client mode. Because we want to use the Modbus RTU protocol, we will click OK. In this section, a window will open for us and we need to fill in this table. In the previous tutorials, we explained this table in detail. I will just say that what we want to do now is that we came here and used 2 writes, one of which is related to the frequency and the other is related to the run and stop of our drive. So first we came to the Modbus R2B client, which itself provides us with the P2P function, and we put the conditional flag on the right. We put T 100 milliseconds in the comment on our single data type on the word variable name on a station, which is related to the station drive, and we set it to 1. If we click on this part, a window will open for us that has a read area and a save area. The read area is related to the frequency, so we put the frequency that we want to put on the drive in the buffer. There is a save area. This save area is the Modbus address that is related to the drive. Now we can use any drive we want. If you read the drive manual, there is a section that has a table that is related to the hex addresses that are related to its Modbus network. So in the LS drive, the hex address is related to the frequency, the 5 address, which in the LS PLCs, we subtract 1 from it and put the 4 address. And this 40,000 that you see here is related to our write operation. That is if we want to do something. For example, here we want to transfer the frequency from the PLC to the drive for writing. We use 4000, but for reading we use 3000. The second line is related to run and stop. So again, we fill them in the same way as the first line. The only difference with the first line is in the last part where we have a read area and a save area, which is the read area. We put word 200. Save area is a hexadecimal address that is related to run and stop, which is address 6 in the LS drive, and we subtract 1 from it and put 5. This first 4000 is related to writing. Now in the program environment, what we do next is that we have used a MOSFET. This first part is related to the frequency. Now here in the input of this MOSFET, we enter the frequency we want. For example, I want the frequency to be 50. We enter the frequency of 50 and 2 extra zeros, which now corresponds to the index number that the drive has. 2 extra zeros are also needed. Let's enter, so I'm entering 5000 here, which is the frequency of 50. We also mentioned the 100, which is related to the frequency. In this part, we used 3 more moves. We put one of these for forward, one for reverse, and 1 for stop. In the enable section of these moves, we also used a normally open contact. I put the address of the first one as IX 0.0.0, which is related to our forward. That is, whenever we activate the start button that we connected to the PLC, this move will be enabled and the number 2 will be put into MWord 200. As you can see in the image, if we put 2 to that address number 5, which is related to our door and stop, this address 5, which is related to our run and stop, we give the number 2 to that address through this MWord 200, our drive will work in forward mode. And if we give the number 4 to this MWord, that is, let's move into this MWord 200, which is now related to the address of at least 5 of our drives. Our drive works in reverse mode. If we move the number 1 into MWord 200, our drive works in stub mode. The point is that here I used a normally closed contact. The reason is that the switch I used for stub was a normally closed switch. So here I have to use this as a closed contact, because if I use it open here, it will always be in stub mode. So since I used a stub switch there, I used this as a normally closed contact. Now let's test the program together and see how it works. As you can see, we set the frequency to 50, which appeared on our drive. Now we want to give a command to our drive through these contacts. See, the first contact is reverse, so our drive is working in reverse mode. Our frequency has reached 50. Here I stub, we see that it has stopped, and this is what is related to forward. Look, it's working in forward mode now, and if I try to restart it, our developer will stop.